Hello Year 11 and welcome to our third video here for our 10th unit. The unit is measurement. The third exercise is significant figures. Hopefully you've seen some of these before. We're going to go over them again. Significant figures is a way of rounding off our measurements. As we saw in the previous exercise, none of our measurements are perfect, are exact. They're always rounded off, right, according to the precision of the device that we're measuring with. Now, significant figures, instead of just saying so many decimal places, well, this significant figures kind of makes it independent of units. We get the same absolute error regardless of what units we're using. So, a quick reminder. Significant figures. Any non-zeros are significant. Right. Any zeros to the left of the first non-zero are insignificant. Zeros in the middle, right, between non-zeros are significant. Zeros at the end after the decimal place are significant. Zeros at the end without any decimal place, well, it's hard to know. Right, there's some rules there. I think it really helps to get stuck in and have a look at some of these. So, how many significant figures are in each of these measurements? Look at this first one here. Now, zeros at the beginning, they don't count. Okay, so let's see how we go here with this thing. Right, so they're not significant. Right, zeros at the start. They're just to give me place value. But I've got 1, 2, right, so that's significant. Right, 0 is because it's in the middle. And a 0 at the end after a decimal place is definitely significant. So that's 5. 5 significant figures, right, like that. Okay, now over here, this one is, oops, right, non-zeros are significant. What about these ones? Well, the thing is we don't know. Has that been rounded off to the nearest whole number? Has it been rounded off to the nearest 10? It's been rounded off to the nearest 100. Has it been rounded off to the nearest 1,000? No, definitely not. Maybe it's been rounded to the nearest 100. Maybe to the nearest unit, right? But we don't know. Okay, it's hard to tell from that. So that might be 4, 3, or 2 significant figures. You really can't tell with a question like that. So you tend not to be asked them. Right? Maybe it's exactly 4,300. Maybe it's only approximately 4,300. Anyway, back over here. Now, this, right, has the same value. In some respects, they're the same number. But the 0.0 at the end means this definitely hasn't been rounded off to the nearest 100. Okay? That hasn't been rounded to the nearest 100, to the nearest 10, or even the nearest unit. This is suggesting that to the nearest 1 decimal place, which means that 1, 2, 3, 4, 5 significant figures here. Okay, so once again, this is 5 significant figures. Now, the previous one can't be 5 because we would have to have a 0.0 there. Okay, to indicate the 5, but it might be 2, might be 3, might be 4 significant figures. Moving along now, I've got a couple of tape measures here. You can see they have different precisions. My first tape here has a precision of 1 centimetre. My second tape here, precision of 1 millimetre. Now, part A says, what is the measurement shown on each tape, and how many significant figures does the measurement have? Well, for tape A, right, let's try this. My measurement is 28 centimetres, and that is 2 significant figures. But for tape B, well, again, it looks like 28, right? 28, but we can actually say it's 28.0 because we should. Centimetres, that's 3 significant figures this time. Righto? Now, which of the two measurements is more accurate? Well, certainly tape B is. Right, my absolute error for tape B is plus or minus half a millimetre. My absolute error for tape A is plus or minus half a centimetre. Now, Maurice, good old Maurice, recorded a measurement of 57.4 centimeters using tape A. What should he have written and why? Okay, now there is no 0.4 marked on tape A, so Maurice is guessing. Right? He sees it's between 57 and 58, but he assumes it's about 57.4. He's guessed, but he should have said merely 57 centimeters, and he could say plus or minus half a centimeter. Right? And that covers the 57.4. It could be as much as that. Now, Miriam records measurement of 19 centimeters using tape B. Well, it's a bit like this part here, where we said because we can, we should. So it wouldn't be 19, it would be 19.0. Same value, right? Different accuracy. So, oops, doesn't work very well unless I'm in precision mode. No, that's so scruffy. And I don't like using the eraser. 19.0 centimeters, because this oops, I'm going to have to come to the eraser, hang on. Okay, let's get rid of some of these. Okay, back to my pen. Now, we can say 19.0 plus or minus 0.05 centimeters. Okay, because that shows to indicate the precision. Rightio? Because we can, we should. Rightio, that's significant figures. That's the end of this video. What did we learn here? Remember, we can count significant figures. Mostly it's the non-zeros. Zeros in the middle, also significant. Zeros to the left, not significant. Zeros to the right, after the decimal point, significant. Before the decimal point, hard to say. Okay. Now we can round off to a certain number of significant figures. That's fine. We can read something now and include a sort of a caveat, right? The absolute error on that. Okay, and we know that we shouldn't be sort of guessing in between graduations on our measuring device. Okay, that's it. If you've got any questions, you know what to do. Jot them down, ask me in class. See you then.